ก็ขอสวัสดีทุกท่านนะครับก็ยินดีต้อนรับเข้าสู่เซสชั่นเวบินาร์อย่างเป็นทางการนะครับวันนี้เราจะมาพูดคุยกันในหัวข้อEdgecore 100G 400G Datacenter Solution นะครับโดย Edgecore Network ผู้ผลิต Datacenter Switch รายใหญ่ของโลกซึ่งจะทำให้ทุกท่านมารู้จักคอนเซ็ปต์ของ Datacenter ในยุคใหม่ภายใต้คอนเซ็ปต์ Open Networking นะครับเซสชั่นสัมมนาในวันนี้จะดำเนินประมาณบ่าย2กว่านี้ครับถึงประมาณบ่าย3นะครับก็แล้วก็ปัจจุบันนะครับหลายๆท่านก็ทำงานอยู่ในแวดวง Data Center มาพอสมควรแล้วก็น่าจะทราบกันดีว่ายิ่งนานวันเข้าไปก็ยิ่งมีความต้องการในการใช้งานตัวสวิตช์หรือว่า Infrastructure ใน Data Center ที่ใหญ่ขึ้นเรื่อยๆรองรับกับความต้องการของผู้ใช้งานที่มากขึ้นในยุคปัจจุบันทั้งในเรื่องของความเร็วแล้วก็ในเรื่องของข้อมูลต่างๆที่มากขึ้นนะครับทำให้งบประมาณของ Data Center เนี่ยถูกเพิ่มมากขึ้นอยู่ในทุกๆวันเพราะว่าสวิตช์ก็ต้องใหญ่ขึ้นราคาก็ต้องสูงขึ้นแล้วก็ในปัจจุบันเนี่ยแบรนด์ใหญ่ยักษ์ใหญ่หลายๆค่ายก็จะมีค่าใช้จ่ายทั้งในเรื่องของฮาร์ดแวร์แล้วก็ในเรื่องของไลเซนส์ที่จะตามมาเป็นไม่ว่าจะเป็นรายปีหรือว่ารายต่างๆนะครับก็ทำให้ในโลกก็เกิดการรวมตัวกันแล้วก็พยายามที่จะคิดคอนเซปต์ใหม่ๆออกมาก็เลยเป็นที่มาของคอนเซปต์คล้ายๆ decentralize ตัว Data Center นะครับซึ่งเราจะแยกตัวฮาร์ดแวร์กับซอฟต์แวร์ออกจากกันทีนี้หลังจากนี้เราจะสามารถใช้ฮาร์ดแวร์ในค่ายใดก็ตามโดยที่ไม่ผูกมัดกับซอฟต์แวร์นะครับฮาร์ดแวร์จะเป็นยี่ห้ออะไรก็ได้แล้วก็ซอฟต์แวร์ก็จะเป็นยี่ห้ออะไรก็ได้มาทำงานบนมาตรฐานเดียวกันนะครับวันนี้เราได้รับเกียรติจากคุณเอสมอนนีโอนะครับ Sales Manager ประจำ APAC Division นะครับจาก Edgecore Network นะครับจะมาเล่าให้เราฟังเกี่ยวกับการ accelerate Open Networking ในยุคอนาคตนะครับ Please introduce Mr. Esmond Neo, Sales Manager from Edgecore Network. Okay, Esmond, please.
Thank you, H. Hello, good afternoon, everyone. My name is Esmond. I'm from Edgecore Network. Today, I'm very glad to be invited by EasyNetwork to share these open networking solutions to you all for the market, the emerging technology in the market right now. So let me start with it. So before we go into, I'm not sure how many of you all heard of Edgecore Networks or Edgecore products. Actually, we are one of the brand business under our Acton Group. So people ask, who is Acton Group? So allow me to do a short introduction on our Acton Group. Over here, you can see our organization chart. Acton Group is the one that is holding all the design platform, the manufacturing, the brand business, and also the foundations for the charities. For under Acton, we have the design and development started since 1988, mainly doing the ODM business and also IoT solutions. And under our manufacturing plants, we have manufacturing plants in Taiwan. Previously, there are 2, and because of the recent last year trade war between the US and China, so that's why we acquire another SMT line from Taiwan also in Taiwan. So right now we have 8 SMT line in total in Taiwan, manufacturing switches for data centers for the open networking solutions. And other than Taiwan, we have 18 SMT line in China, Shenzhen, manufacturing mainly our enterprise switches and also our Wi-Fi solutions. So under Actem Group, Edgecore is the brand business in the market doing open networking solutions, enterprise switches, Wi-Fi solutions. And also under our Actem Group, we also have this EasyNetwork brand doing cloud-based Wi-Fi solutions, point-to-point, point-to-multipoint, which EasyNetwork are also selling these products. And other than that, we are also the owner of the SMC networks. I think many years back in Thailand, you see this brand normally doing those unmanaged switch and very basic layer 2 switches, or even your home routers. So other than that, we also have our charity foundations under Actem Group. The Up Foundations is being set up in our HQ in Taiwan, Hsinchu, helping those having difficulties. So we believe that we receive from the society and we contribute back to the society. So allow me to go into next slides. So for Actem Group, is a leading ODM and OEM company in the market. So we are founded in 1988 and we are IPO in 1995. Throughout the years, our revenue have been increasingly because of the open networking solutions that we are working in the industrial. For last year, we clicked about 1.8 billion revenues for 2019 under our Actem Group. And currently we have 5,415 staff worldwide, having a support of 1,000 network engineers, and we have our own R&D centers. We are a volume manufacturing in China and Taiwan, and we are so-called the one-stop shops. So there's a market survey in 2011, out of 100 switches, 100 switches, which is non-Cisco proprietary type of switches, 42% is manufactured by our Actem Group, our company. Basically, you will see those brands in the market like HP, Junipers, 3Com, and all these. These are our customer from Actem side. We manufacture the switches for them. So in the market, out of hundreds, 42 are from this factory in Taiwan. So for Edgecore side, we are fully owned and subsidies of Actem Group, and it started in 2004 and we spin off in 2010. And we are so-called the leader in the open networking technology at the moment. And we have our worldwide presence and offices. We have our offices in the US, in APAC, for me in Singapore, and also our guys in the Europe and representative everywhere in the world. So under our Edgecore missions, we are trying to deliver those very cost competitive traditional network to the industrials, and also leading the open networking industrial in this current technology. So under Edgecore, we have different product segments. For what I mentioned earlier, we have our data center switches for the telcos, and also our wireless solutions, and the enterprise switches for the carrier. So under our Edgecore Group, our product segments, we have the data center switches from a very basic 1G all the way up to 100G. Actually, right now, we already have the 400G switches. And to share with you all the informations, actually this year or maybe earlier next year, we will be launching the 800G switches, which means every single port is 800G. And we are the #1 contributor to the OCP. Later, I'll explain a bit more on the OCP. And for our wireless products, we have the indoor and outdoor and the APs, the controller base, and also the enterprise switches. We have the layer 2 and layer 3 switches consists of 8 port all the way up to 48 ports, be PoE or non-PoE, supporting IPv4 and IPv6. So on the left side here is our switches for our data center. And those in the middle is our switches for the enterprise solutions, which I mentioned earlier, those layer 2 and layer 3 switches. And also our wet smart switch and our wet smart pole, a very basic entry level. And also those industrial switches, which support high temperature for the outdoor usage. And also on the right is our enterprise Wi-Fi solutions. Okay, so I'm not sure how many of you all heard of open networking right now. If you heard a lot of things in the market like SDN, SD-WAN, NFV, and so on, all these are categorized under the open networking solutions in the market. So let me explain further into it. What is open networking? Okay, open networking is when open hardware meet open software, which means that in a example, give you a very simple example. I believe today everybody carry a smartphone, maybe a Samsung phone, an Apple phone, or a Huawei phone, or whatever. Most of them are using different OS running. For the iPhone, they have the iOS. For the Samsung phone or Huawei or whatever brand, they are using the Android. So when you purchase an iPhone, but you don't like to use the OS inside, and you don't like to use the iOS, you can uninstall it and then install the Android that you want. So same goes to the same things to the switches for open networking, which means there is a de-aggregation of the hardware and the software. So what does open networking benefit you? It gives you the freedom, the control, and the innovations. Later, I'll explain more on these portions about the freedom, the control, and the innovations from there. So just now I mentioned earlier, OCP. So actually OCP is started by Facebook and some very big telcos like AT&T and also Amazon. So all these are our customer in fact. So they started this OCP. One of the main reasons is the high usage. The high usage of the devices in the data centers. So in the past, Facebook and Amazon, they used to purchase those traditional, maybe Cisco or Juniper or HP or so-called switches or Arista. So they find that every year they have to pay a lot of maintenance fees, and basically they are paying a lot of things that they don't really use it. So all when people know that, I mean, in Facebook, they have a lot of those high, very good engineers inside Facebook. So they came out with these solutions. They write their own software and they run it on to the hardware that they want. So actually, Facebook came into Acton, came to Edgecore, and wanted us to join them to participate in this OCP and start contributing to the hardware platform onto this OCP. So the reason is to reduce the CAPEX, the OPEX, and the total cost of owning the device. And one of the good advantage is you can scale up very easily, which means that you can start very small. Either you as a user or any customer that they want to set up their own network in their own office, they can start actually very small with maybe one rack or two racks. Later, I'll explain a little bit more on the topology, how you start up very small and how you grow while you are scaling. Another reason is also the power and space saving. In the past, data centers have these problems that they do not have enough rack space. All those traces is taking up very huge large space. Example, maybe 5U, 6U, 8U, 10U of the racks. So space is very limited and it's very costly. Today, data center operators, their income is made on all the user that is tapping onto their DC infrastructures. So in order to save more rack space, they can put in more devices to support more customers. So, and another thing is very important is no vendor lock-in, okay, which I just now explained very early. Reason why no vendor lock-in is because of paying all those annual fee and things that they don't want. So they actually can change it, remove the software that they don't want and then pay something that they wanted. So as I mentioned just now earlier, Edgecore contribute to the OCP with the invitations of the Facebook and Amazon. So for Edgecore side, we are contributing on the hardware portions. This is Edgecore, contribute more on the hardware. And for the other commercial software, they are contributing on the software portions. And there's also the open source community. So for the open source community, you'll see something like the SDN controllers or network operating system, which is from the open source, which is free, and there's no license fee. Later on, I'll explain more a little bit on these portions, which will really help you save costs and also develop from there. Okay, so this is a switch that we manufactured for Facebook in the very, very early stage in 2012 and 13 during that time. Facebook is the first to start a 40G switches in their network. At that time, most of the people is using a 10G switch. Is considered a very high-end switches. And Facebook came to us, we designed, Facebook designed the outlook of the switch. So that's why you see it's in blue color, it's the Facebook color. And Atom manufacture it and Edgecore doing the fulfillment channel for them, distribute it to Facebook site. So actually in this part, Atom's design platform and the Edgecore working hand in hand to supply the requirement for Facebook design. And about 3 to 4 years ago, we started to provide Facebook for the 100G switches. And today, they are not using 100G. They are using the 400G switches in their data centers. And share with you all a little bit small secrets. Today, every month, Facebook and Amazon are taking out about 5,000 pieces of 400G switch every month, which means that they are increasing their data centers very often, very usual, and moving into a very huge bandwidth in their data centers. And these have been going on for the past 1 to 2 years. And we believe the next things that is going to push them will be the 800G. So these are some of the switches that we contribute to the OCPs. We contribute the 1G and 10G and 100G, and also some wedge model. Later I'll explain a little bit more on these portions. The wedge which is Facebook is using, and also another wedge that is using a different chipset for those hyperscale customers. Okay, let me take you into a very basic understanding of why we are moving it from the open networking, moving into the open networking solutions. In the past, data center is using those traditional chassis switch, which you can see it over here on the top left-hand side, over here. A very traditional chassis switch is basically very expensive in the first place, and it's rely a lot on the backplate. And once the backplate fail, the whole chassis switch will fail, and there's no redundancy over here. And once the port is full, the user or will have to purchase another chassis to add on onto the network, which is very expensive just because of a few more ports that you want to add on to it. So, for your understanding, a traditional chassis switch consists of the backplate over here, the line card, and the supervisor. So how we are transforming this into the open networking solutions by using a pizza box to replace it. In the past, I don't say in the past, today, if you know, when you purchase a server, it's basically a bare metal server, which means that there's nothing inside except for the BIOS and the PSE. And so we implemented from the bare metal server into a bare metal switch over here. Okay, same as the server, we have the U-boot and the ONIE to replace the BIOS and the PSE in the server. So all bare metal switch, or I can say that all open networking switches in the market will come with these two things. And this ONIE stands for Open Networking Installation Environments. This has become an industrial standards, just like those that you have been doing, understand from the networking industrial standard like IEEE. ONIE has become an industrial standard for the open networking solutions. This is innovated by Edgecore and also Cumulus, one of the commercial software in the market. Later, I'll share a little bit on the Cumulus side. And on top of the ONIE, once you load in the network operating systems, you can load in the applications that you want and then they operate from there. So let me get back to how we replace the traditional chassis to become a topology for the networking infra. So when I mentioned earlier, traditional chassis will consist of a backplate. So from the backplate, we use spine switches to replace the backplate, and also the leaf switches to replace the line card. And the supervisor portions will use the SDN controllers to replace it. So the data plate is over here, and the control plate is over here. And this is what in the market we call it open software-defined networks. Okay, reason is to reduce the OPEX, CAPEX, and the flexibility of this topology. So let me add on something over here. Just now earlier I mentioned that open networkings that you heard of like SDN, SD-WAN, and NFV. For SDN, is a software-defined networks. It will require a software SDN controller, which I mentioned over here. Okay, but for NFV solutions, which I mentioned earlier just now, like the Cumulus, they will not work with. They do not require a controllers to work from there. So they are called the NFV solutions, using these intent-based networking solutions to control all the traffic over here. And not only these cross topologies that is having a redundancy, as you can see, at any time any of the spine was down, the whole topology is still running. This is a cross topology that we will call in the open networking solutions. So unlike the traditional chassis switch, when the backplate fail, the whole chassis will fail. So this is the cross topology that we always mention in the open networking solutions. And who are the guys that is deploying this cross topology in their data centers? It's over here. Google's, Facebook, and Amazon. Who started all these things? The cross topology started since in the past when the telephone system was using those pitching style of infrastructures. So we use the solutions, implement it over to the network side to become the cross topology in this topology you see over here. So let me show you how's the difference between the traditional topology and the cross topology benefit for you, and how are the advantage and disadvantage. For the traditional topology, it's not designed for today's data centers running modern workload. Why? Because of the increase in the server density, the increase of the server to server traffic, which means in the past, traffic is moving from the south to the north or north to the south, which means that in the past, when you surf an internet, you went to a page, normally you would just stay around there. You don't move your traffic here and there. But today's is different. Take a look at Facebook. I believe most of y'all have a Facebook, or maybe Instagram, or any other connectivities like a line and all these things. So basically, all your traffic is moving within the data centers, which is the east to the west. And in the past, this topology is not easy to scale up when using a traditional chassis. So when it's full, you have to keep on adding on chassis to support this infra. But today, I believe most of y'all were serving those social medias, or even doing some purchasing on the e-commerce platform. I don't think you will feel the lag on that portions on the website, on the server, because of this cross topology in their data centers. Traffic is moving within there, and it's easily to attract all this traffic, and then to configure where the traffic will move into different racks, and also the redundancy over here. And something to add on the redundancy, all Edgecore switches will come with 2 redundant power supply, and also 4 to 5 redundant fans, which means that anytime the power is failed, you can just replace it without shutting the switch down. So the benefit is to have a fewer protocol, which you don't need to pay like those traditional chassis switch, lesser proprietary features. In the past, I think, don't say in the past, even now, a lot of users are still paying for those proprietary features that A and B, C company that is offering, but most of the time users are not really using on this. And actually you are paying things that you don't use. And advantage is every leaf is one hop away. You enjoy the predictable latency, and it's a horizontal scaling, which means that at any time when the rack is full, you can just add on another switches, a leaf switch, to continue adding on and so on, to increase your data center's volume. And when I just now mentioned, you can start small and scale up. The very, very basic that you require is 2 spine switch and 2 to 4 leaf switch from here. So you can do your ECMP, MLAX, BGP routings all over here.
Okay, let's go ahead.
Okay, I saw questions, right? Do we need the efficiency switch that connect to the internet? No, actually from the leaf switch, you can connect all the way to the gateway or to your firewall. Yep, usage to the core. There's a slides after this. We'll show you how you connect to the internet from here. So before I go into the previous questions just now, let me go a little bit more into the software that will explain what type of environment will use what type of software. Using a different software will cut down the cost of the software portions. Just like I mentioned very earlier, traditional user, they normally will purchase a lot of features that they don't actually use, which means that you're buying a traditional chassis switch, or you're buying a ABC branded switch, give you proprietary stuff, but you don't really use it. And in fact, you are paying all those price, paying all those costs, the license, the software, here and there. So in order to meet the requirements in the market, for the user. Actually, to share with you all something over here, based on for the past few years that we have been doing, proposing, deploying solutions to the customer for open networking around the world, in the US, in the Europe, even in Asia, in APAC regions, we noticed that most of the customers, they don't really need those features. And in fact, they just need a few features that they will require them to use it. So in fact, when you don't use so much, you don't pay for those unnecessary things that you don't use. So over here, we have a different software, which I will highlight a little bit, where all these are commercial software that you can just go and Google around to understand a bit more on that portions. So over here, we have this Cumulus that I mentioned earlier. We started the industry standard for open networking that we came up with them, the ONIE, Open Networking Installation Environment. Okay, if today people say that, oh, I have a bare metal switch, then ask them one thing. Is it come with an ONIE? If no, then there's not a bare metal switch, which means that you can't remove the software from there. And for Cumulus side, they are the NFV. They don't really require a SDN controller to work with them. So basically for a switch, bare metal switch, you just install the Cumulus software on top of that, and you can use different monitoring platform to get your orchestrations and automations from there. One of the very popular one will be from Red Hat, the open source software that been acquired by IBM about 1-2 years ago. They are using the Ansible Star Wars and Ansible Engine. One of them is a free one, the other one is a paid one. So you can, from there, you can do your automations and more management and monitoring from there. And next things over here is a very full-scale traditional open networking software. I can say they are a bit close. They're using the software-defined network using their own SDN controller and their software to run the operating system for the data centers. So they actually, Big Switch have two applications from their software. One is the Big Cloud Fabric, meant for the data centers. The other one is Big Tap, or maybe they call it the Big Monitoring Fabric, which works as a network packet broker. Okay, network packet broker, if you heard of it, mostly in the market, maybe it's like NetScout or Ixia or Gigamon, this type of solutions. So Big Switch is actually one of the players for the network packet broker using their SDN controller and also the bare metal switches. And another solutions in the market is called Pika8. This is a very interesting one. Maybe until now, you ask me, oh, I don't have such big DC, and I don't have to set up something so big like Facebook, Google, Amazon. So how am I going to enjoy the benefit from using open networking switches? How do I enjoy it? How do I follow up with the technology in the market today? So Pika is another solutions in the market. They serve the same purpose like those traditional layer 2 or layer 3 switches over here. And they come with the OpenFlow features. OpenFlow features is a protocol that talks with the SDN controller. So in order for the SDN controller to talk to the switch, all the switch must come with OpenFlow features, a protocol to talk to. And they can use a third-party SDN controller like Floodlight, Re, or Open Daylight, or those that is is free, where you can download from the internet, the SDN controller. This serves a very big difference with between Pika8 and the Big Switch. Big Switch will require to use their own Big Switch controller. So these portions, they are a little bit proprietary, not fully open, whereby Pika8 is a more open type of solutions. And For small scale enterprise, most of them will choose to use a Cumulus for their racks. But for campus, school, universities, most of them will prefer to have a PK8. Reason is because of the open flow features over here. And I did a couple of cases in Singapore and other countries over here. Most of the universities, they will deploy PK8 solutions with our switch in their lab with the open flow features. And the reason or the objective to achieve that is for the students to implement their own SDN controller and also to familiar what does the controller can do. So over here, share with you something about 2 months back. We also installed the open networking solutions for the labs in one of the Singapore government universities over here. So same over here, they can use the same management and automations platform for like the Puppet, the Chef, the CF engines, which you can find from the website. And next is something Broadcom. Broadcom also have their own software, but basically right now they do not resell their Broadcom software in the market. So they're using the layer 2 and layer 3 with the open flow and also work with the third-party controller. Okay, something to share with you all. Broadcom, as we all know, or maybe just share with you all, Broadcom is the biggest chipset manufacturing in the world right now. In the market survey, Broadcom have about 90 to 95% of the market share for a chipset. So all the switches in the world will require a chipset to run. And Broadcom have the market share of about 90 to 95%. So most of the chipset that we are using in the open networking solutions come from Broadcom. So this is something for you all to know, okay? Just like Intel for the processors, the CPU. And next, another thing is IP infusions, something that you all can look around. So just now I highlighted something that, oh, you don't pay so many features that you don't use. And I believe a lot of big brands in the market, they are providing those MPLS features in a switch, which customer don't use. And the switches that support MPLS is very expensive. Okay, and actually, to highlight something, MPLS is a very old protocol. And today, most of the open networking user, they don't really use MPLS in the network. And what are they using actually? They are using EVPN or VLAN or maybe BGP routings to overcome these MPLS requirements. But there are still some customer that will require MPLS. So today, if you really, I need to have an MPLS. So most of the open networking software do not support MPLS because this is a very old technology. So if they are not willing to move forward into BGP routing or EVPN, these type of things, then they have to stick back to the MPLS. So I would suggest that they will go for the choosing the software like IP infusions. So this is one of their plus points. So if you want to replace maybe a traditional Arista switch or Cisco switch, you can use the IPI infusions software to comply with the Cisco or whoever brand's requirements for the MPLS. And next is Paribus networks. They are so-called a server switch, and they're mainly using the software-defined fabric to do network slicing or segment routing, these sort of features. So far, any questions for the software portions?
Esmond, how about Sonic?
Okay, good. Sonic is an open source software. is implemented by Microsoft. So this gentleman, Mr. Song Khan, is it? Wow, I think you follow a lot on the open networking solutions. Okay, Sonics I mentioned this is by Microsoft. It's an open source software. When you can download it and then just run it on the open networking switches. One good news for you all, from this year onwards, in the past, some of the models do not support Sonic's platform because the time Sonic was not ready in the market and not mature enough. But from this year onwards, those latest chips are open networking switches that came out from Edgecore, running on those Trident 3 chipset, Tomahawk, and others like Jericho's and all these. They are able to support Sonics, which means that when you purchase an Edgecore switch from us, and you can just download the Sonics and then run it onto the white box without paying any additional license fee. So there's a good advantage and a bad advantage. The pro and cons. Okay, the pro is don't need to pay any things for the software, don't need to pay any license fee. But for a big enterprise, sometimes it's better to pay a little to pay some. A reason why, okay, because when there's something happens to the software, having a software issues, definitely you want someone to have a support from there. So just to share with you all, Edgecore will be releasing our own Edgecore Sonics, which means that we build on top of the open source Sonics with the software engineers and our R&D team working on these Sonics. So in the market coming down, you can purchase an Edgecore switch, come with an Edgecore Sonics, which means that there are support from Edgecore. So when anytime the Sonics having problem, our support team will provide you the support from there. But the fee will be slightly cheaper than any of the software over here. As compared to the open source, when you're having an issue when you install a Sonics on the bare metals, and when something happens, you will have to go to the GitHub and then to request help from those engineers over there. Okay, do I answer your questions, Songka?
Yep.
I saw some questions over here, white box switch and a bare metal switch or cumulus SDN control. So I can't understand the Thai.
The first one from Kun Ponpitak, white box switch versus bare metal switch. How different between two of these? Okay,
bare metal switch is just now I mentioned it's just a server. It comes without any software. This is called bare metal switch. A white box switch is maybe like today, I want to use IP infusions over here. So you can purchase from EasyNetwork. Edgecore switch come with IP infusion software. So which means that you're buying an IP infusion solutions. So the box will deliver to you with IP infusion solutions inside the Edgecore box. So that is what we call the white box. And there are another thing in the market, we call it the bright box. Bright box is something, example, this is HP. When you're going to purchase an open networking solution from HP, HP will provide you the box with the open networking solutions inside, but they name it as HP. So actually, the whole thing is the same. You're getting the same box, same software, but there's a bright box, we will charge you more expensive. So for a difference between the white box and the bare metal switch is one with the OS, one without the OS. So I hope I answer your questions.
ครับก็สรุปแล้ว bare metal switch เนี่ยก็จะคือสวิตช์ที่ใช้ใน open networking นะครับซึ่งจะเป็นสวิตช์เปล่าๆแล้วก็ต้องหาซอฟต์แวร์ไลเซนส์เข้ามาลงเพื่อร่วมกันใช้นะครับส่วน white box switch เหมือนกับเป็น สวิตช์ที่เหมือนกับ OEM เป็นยี่ห้ออะไรก็ได้นะครับจะเป็นคนละแบบกันครับไวท์บ็อกซ์นี่ก็จะขึ้นอยู่กับนโยบายของแต่ละเวนเดอร์นะครับว่าแต่ละค่ายจะมีไวท์บ็อกซ์เป็นยังไงบ้างคอนดิชันยังไงแล้วก็ราคายังไงนะครับโอเค is one another question
I saw the word cumulus and SDN controller.
Yep.
Can translate for me?
If they use cumulus, is it necessary to use SDN controller?
No. Okay. SDN controller is basically a server. You need a server you need to install the SDN controllers onto the server. Okay, but for Cumulus, no. They use the automations on an intent base, which means that just now I explained, you can just go and download the NCPers, and then from there you can just do those automations and managements from there. Or even actually, Cumulus also have their own somehow like a controller, but it's not a physical controller. It's called NetQ. So you guys can understand a little bit more tomorrow. Okay, tomorrow there's a session for Cumulus, and on top of Cumulus, there's another intent-based networking solutions which can work with Cumulus on Edgecore switch and also other brands like Junipers or Cisco and all these things. Actually, there's the one that I think EasyNetwork is going to introduce to you is very interesting. So I hope you all will attend tomorrow and the Thursday events also. So from there, they will explain more to you. Okay?
โอเคครับก็สำหรับ Cumulus ก็จริงๆแล้ว Cumulus เนี่ยโดยพื้นฐานเขาจะมี automation อยู่ในตัวอยู่แล้วนะครับก็ถ้าในสเกลเล็กๆเนี่ยก็จะไม่จำเป็นต้องมี SDN controller ครับแล้วก็สำหรับโซลูชันที่ใหญ่ขึ้นเนี่ยเขาก็จะมี Cumulus NetQ ซึ่งจะเป็นคล้ายๆ monitoring ที่มาตอบโจทย์ในสเกลใหญ่ๆนะครับก็ผมขออนุญาตประชาสัมพันธ์วันพรุ่งนี้ไปในตัวนะครับอันนี้เราเป็นเว็บบินาร์ซีรีส์นะครับคือวันนี้จะเป็นเรื่องของฮาร์ดแวร์มาทาง Vendor Edgecore สำหรับพรุ่งนี้เราจะลงลึกไปที่ Cumulus นะครับก็จะพูดถึง Cumulus OS ว่าจะมาตอบโจทย์ในคอนเซปต์ของ Networking ยังไงบ้างแล้วก็ Cumulus ในปัจจุบันนี้ก็เป็นผู้นำตลาดของ OS อยู่แล้วนะครับเดี๋ยวพรุ่งนี้เราจะมาลงลึกในส่วนนี้กันนะครับก็ขอบคุณสำหรับคำถามนะครับโอเค please go ahead
Okay, so let me go to the next one. Example of how the topology looks like. This is a small cross architecture, single tier spine. Over here, you can see it consists of the spine switch and the leaf switch. So sometimes people ask me, oh, how many server and storage I can serve from this cross topology? This is an old scale. Using the 40G switches, the 40G switches will have consist of 32 ports, 32 of 40G each. So over here, we're using the top of the rack switch with the lead switch with 48 ports, 10G switch. So this is a little bit old, the scaling, using a 32 ports 40G switch. Today, switches over here is already 100G. And not only 32 port, we have switches model like 64 ports and even up to 128 ports. So the number of server and storage can serve will be different from this amount. It might be about 10 times more than this. And another things, I think earlier we mentioned like just now how, I think there's a questions over here that do you need to connect to the internet? Yeah. From here, this is where you connect the leaf to your WAN, to the internet. So this is a spine and a leaf topology. So sometimes when a large scale topology over here like this, they will scale up over here, and this portion is called the border leaf, which connect to the WAN. Or even if you do not want the border leaf, you can use any of the switch over here, connect to the WAN. To another call. One thing for this environment is very good enough for telcos. I think in CATS or TOT in Thailand is already enough for their deployments. Okay, just for your info. And next one, you see this is a 2-tier spine and leaf, which means that this topology will consist of a super spine over here. So when you see just now there's a spine switch over here connecting to the leaf switch over here, and sometimes ask me, people ask me, oh, what happened is fully populated. So from there I can branch out to another spine and the leaf and then connect both sides together using a super spine over here. So this topology until today is actually deployed by Amazon and Facebook, which use the super spines. Or in fact, if you have a couple of data centers that you want to connect together and it's very huge skills, then you will require to use a super spine from here. Otherwise, a traditional spine and leaf will be enough to serve the needs. So this is one of the use case that we deploy in the data center using the leaf and spines fabric, using the SDN controller for the SDN applications. This is the cross topology using a 40G and 100G mixtures connecting to the 10G and 25G's leaf switch. Normally the leaf switch in the data center, we call it the top of the rack. TOR, top of the rack. And then connect to the data center interconnectivities over here. Okay, next is another use case that we call it the core. Okay, over here, core. Why we call it core is because it's a central office re-architect as a data center. So we call it the core. This same, using leaf and spine fabric, connecting all the open networking switches, connected to the current customer's PON or OLT, the MEF or open switch, the doors, the radio access networks, and also the VNF white box servers, using the open source controller, supporting BGP apps and networks, and also the controlling apps. So this is a cloud management and service orchestrations. Another one is over here that we did it with links. We call it links. Links stand for London Internet Exchange. Something similar to, I think in Thailand, we have this called TCC, or in Asia or US, we call it Equinix. So they are providing those Internet Exchange. So we deployed the open networking solutions using the IPI infusions. In the past, they require us to use MPLS, but we use an EVPN to overcome it. So connecting the 40 and 100G for these links LON2. Okay, LON2 is a slightly smaller scale than the LON1. Little bit to share with you on the history. LON1 is still currently running on the Juniper's network switch, and this LON2 they deployed it using the Extreme network switches. So during one of the years, I can't remember which year, I think there's a World Cup or Euro games that's happening, and during the time there was a lot of switchings from the user when they are watching those soccer match. I can't remember if it's a World Cup or Euro. They are switching the channels and all these things. So from that time, this LON2 failed. The whole network was down. Okay, it's really a big hazard for the links. So after that, they came to us and we brought in IP infusions and we propose these solutions for them and replace away all the extreme network switches using the open networking solutions with IPI on all the LON2, which until now they solve all their problems on LON2. Until today, there are no issues happening there, even with high volume of bandwidth connectivities. So other than these solutions, they are going to do a tech refresh on the LN1 because the Juniper switch has been there for a couple of years and it's time to do a refresh. So basically, we are going to do it with them this year or next year because of the current COVID case. So a lot of things have been slightly a little bit delayed, but we're going to do a refresh for them for the LN1, a very huge skills than this LN2 because of the confidence of these deployments in the LN1. So other than with the confidence of this and a very good skill topology deployed, so a lot of regions customer, they are using they are also the internet exchange. Two of them in Singapore, they came to us, and others in Hong Kong and mainland, they also came to us using our solutions for this because of these very good case studies in links. So all these internet exchange came to us too because they are every day they are doing a lot of exchanging of the huge volume traffics. So they find that these save their costs and it's flexible and it's also easy to deploy and all these things. So most of the internet exchange have already started looking into coming to Edgecore to propose to get us to propose solutions for them, and then for them to do the refresh. So currently we are doing a lot with all those big exchange in the market over here. Okay, another one is SDN case studies that we did with Pika 8 and Chongpa Telecom. These projects, we deployed the Edgecore switches over here, you can see, and also using the SDN controller from Chongpa Telecom, and also the Pika 8 software running inside the Edgecore switch, deployed in these universities in Taiwan. It's called National Chiao Tong Universities. These universities have a lot of IT engineers came into the market. So most of our Edgecore engineers came from these universities in Taiwan. So this is one of a very successful case working hand in hand with Pika 8 software and also the Chongpa Telecom CHT from Taiwan. So it's already deployed using the OpenFlow functions. And next we have this social media in US. The social media in US over here refers to Facebook. Okay, this is the topology that is deployed in Facebook. It's a full cross topology. And not only in Facebook, it's also deployed in one of the ISP in Russia. It's called Yangdek. Okay, until today, I think the very few big guys can deploy such a full cross topology, except for these few big players like Amazon, Facebook, Yangdek, and all these. So these you can take it as a consideration if it happens to scale from there, from a very small deployments. And the next one that we have is a recent effort that we did with Yahoo Japan. This project, we did it with them for their backbone networks, doing a tech refresh for their current infra, 6 data centers in the US and 6 data centers in Japan and 1 data center in US, which we deploy. On the left side over here is sorry, is the topology that Facebook used to have. Yahoo used to have. It's very weak in the east and west traffic. They're using the traditional topology, which is the traffic moving north to the south. And after that, we work with Yahoo very closely with Cumulus software and also the extra intent-based networking solutions together, working hand in hand, and then doing a refresh for Yahoo Japan and transform it into a cross topology. And they have been increasing their east and west traffic very regularly. This is done last year, and Yahoo Japan is very happy with us on all these things. And currently, we're working with another partner in Japan, is Line Japan. I think you all are very familiar with Line. I think most of the people in Thailand will prefer to use a Line. So actually, we are working with them on these portions also. So over here, we have the bare metal switch and a software compliant list. On this table, you will see, hey, how come I see many funny things differently? Okay, over here, when you see, let me take these hot selling models as an example. This is a 10G switch. Okay, the model is 51254X. It's come with 54 10G ports. Sorry, 48 10G ports and 6 40G ports. So those software on the bottom here, you can see Cumulus, PK8, IP Infusion, Big Switch, and so on. Actually, it means that all these software vendors have already certified that they can run on these models on this switch. Which means that different model will support different software. So people ask me, why? How come you all have so many different models and they have to certify that they can run on these models? And example, like you see these models over here, 5912, and only IP Infusion supporting it. Why? Okay, the big reason is because of the chipset running in the switch. These 5812s runs on the Trident 2 chipsets. Sorry, Trident 2 Plus chipset. And this 5912 runs on a Qumran chipset. So for IP Infusions, when they want to run using MPLS features, so the Qumran chipset can support the MPLS features, unlike the Trident 2 Plus that can't support the MPLS features. So that's why when customer wanted to use MPLS for IP Infusions, they will have to choose this hardware instead of this one. Reason is because of different chipset running inside the switch. And not only the base, the fiber port, we also have the base T port, 10G. So reason we come out the 10Gs is also because this will save the cost of buying the transceivers. Because in the past, transceiver is very expensive, but today transceiver is much cheaper than before. But transceiver is still remain expensive for those 100G switches. And we see the price for transceiver has coming down over the years. And today, actually, when I mentioned earlier, Edgecore already have the 400G switch in the market. And 400G switch transceiver is the most expensive right now. So when the 400G came out, then the 100G switch, 100G transceiver have already come down on the pricing. So it's become more affordable and more people are willing to use it. And I remember when about 3 years ago, I remember when I went to Thailand or even in Singapore, in Malaysia, in many Asian countries, when I tell people about 100Gs, they'll just tell me, hey, you're crazy. We don't really need a 100G switch. A 40G is more than, is too much for us. We only run a 10G on our infra. But today, for the past 3 years, we see a lot of requirements came in. Everybody will require a 100G for the spine. And very minimum will require a 10G or 25G. So they really, nowadays, user already know that, the requirement is getting huge. The bandwidth everything to transmit is getting bigger. So instead of using the traditional 1G and the 10G, they encounter a lot of a bottleneck. So, but you will still ask us why we all have still running on the 1G. Because of some customers, the end user, one of the big supermarket that we have in customers in US, they are deploying thousands of this switch in their supermarket every month. Okay, reason is because of they are using these open networking solutions and connecting all their cashier counter and the POS systems to this switch. So from there, their network guys can just configure all the traffic that wanted to move back to their HQs and all these things. So they are using these open networking switches instead of those traditional switches. No? So I carry on. So today, on our Edgecore boxes, we can support more than 20 over network operating system in our Edgecore boxes. So for here, it's just a small scale of software over here. Maybe you can just define it into different sectors. Like for enterprise, most of the enterprise will prefer to use PKI solutions or the campus. So this is, we differentiate them into different categories. So for network packet brokers, I mentioned earlier, we have these NetScout solutions, or Big Switch solutions, or even IXIAs. They are running the same network operating systems, their own network packet broker onto our Edgecore switch. So they are popping all their software onto our Edgecore boxes. So today, very simple. If you buy Edgecore boxes, you want to run NetScout solution, you just buy the NetScout software, you pop on it, you install on it, and then you can run it. And if you feel that, oh, I don't want to use the NetScout solutions and I want to use it for the enterprise, I can just uninstall the NetScout solutions, purchase the PKI solution OS, install onto the boxes, and then you can just run as the open networking switches. Other than that, we also have the Cumulus, most probably for the data center side, or even SnapRoute. SnapRoute is the open source software also. Just now somebody asked me about Sonics. I think he also go and flip through a lot of this. And also for the service provider, normally they will require to have an MPLS. So IP infusions will be one of the choices for them. And also like VOTAs or DriveNets, or even the bigger bandwidth that you require, maybe Arcus or MetaSwitch. So there are a lot of all these software. They are actually able to run on our Edgecore switches. And another thing over here, the Sonics, just now somebody asked me about Sonics. Yes, we support Sonics on the upcoming all boxes, whether it's running on Trident 3 chipset or Tomahawk or Qumran, they are able to support Sonics. And another thing, another software, open source software, you can take a look. This is called Danos. Okay, something similar to Sonics, but this Danos is from IP Infusions. So actually, IP Infusion have 3 types of software. The Danos, they came out with 3 kinds. One is for the AT&T. They did it with AT&T for their AT&T projects. So one is for AT&T, one is for the IP Infusions for the enterprise solutions, and the Danos is for their open source. So if you're looking into Sonics, you might be able to look into Danos also. Take a look at it, no harm. And another one that I would like to highlight is this P4 language. You see this polar bear down here. Okay, P4 is another software. I don't say it's a software. P4 is implemented by Barefoot. Okay, Barefoot is also a chipset manufacturer. Just now I mentioned Broadcom having about 90 to 95% market share. So the rest will go to like Mellanox, to Barefoot or Marvell and all these different vendors. So Barefoot is an emerging chipset vendor in the market. So they claim to be having the fastest chipset on earth, and they are more open on their chipset, which means that they are provide the SDK for the user to do programming, to do telemetries, and writing their own software from this Barefoot chipset. So they're using the programming called P4. Unlike Broadcom, okay, here to share something with you all. Broadcom owns 90 to 95% of the market share. Unfortunately, not everything they release from the SDK of the chipset. So certain things Broadcom will only release out for you to write on your own software. But unlike Barefoot, they're willing to disclose everything from the chipset. So in fact, Barefoot is more open. And last year, because of Barefoot technology, they have been acquired by Intel. So right now, Barefoot is officially under Intel, belongs to Intel. So we see a lot of different market emerging technology coming out, and a lot of big players start to acquire all this. And okay, these things, I think this one happened about a few months ago. Fairview Big Switch, they are also been acquired by Arista. So in the upcoming market, when you see Arista switches coming out doing SDN, mainly they will be using the Big Switch applications from there.